Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering a question from a request from one of my students from one of the end of topic worksheets that I give them from P4, chapter 3. This is Parametric Equations, and this is question number 3 for my worksheet, which corresponds to question number 5 from one of the Solomon papers, Solomon F paper, the old C4 collection. This question here is about parametric equations. It says x equals t over, or a curve has parametric equations, x equals t over 2 minus t, and y equals 1 over 1 plus t, and t varies between minus 1 and 2. So first we got to show that dy dx equals minus a half times, in brackets, 2 minus t over 1 plus t all squared. So basically we've got this equation in parametric form, and we got to find what dy dx is. However, we've got to find dy dx in terms of t. Okay, so we have to use what's called the chain rule in order to achieve this. So we know that the chain rule basically states that if you got dy dx and you want to find, if you got x in terms of y, t, and y in terms of t, then you can rewrite this as dy dt multiplied by dt dx. That's going to give you dy dx. If you multiply dy dt times dt dx. So if you differentiate y with respect to t, and you differentiate x with respect to t, and then you multiply dy dt by the reciprocal of dx dt, which is dt dx, you will get an expression for dy dx. So that's exactly what we're going to do. So let's start with y. We know y is equal to 1 over 1 plus t. Alright, so now this is a type of expression which we can see that you can rewrite this, and you'll have something where you can use the chain rule for, because this is like 1 plus t to the power of negative 1. You can write that in the numerator as a power of negative 1. And then this is something that is not too difficult to differentiate. You can say, well, dy dx, we can differentiate this using the chain rule. Now the main function here is 1 plus t to the power of something. All right, so you multiply by the power, and then you subtract 1 from the power. Okay, and then you multiply by the differential of what's inside the function, which in this case happens to be just 1, so that's fine. So if you write that in, that's dy dt, sorry, not dy dx. If you write that in, it's more kind of like a kind of easier form to deal with. We're going to write this as it's going to be negative, and you're going to have 1 over and 1 plus t all squared. Okay, so that's dy dt. All right, and for dx dt, so we know that x is equal to, as they told us here, 1 over, or t over 2 minus t. T over 2 minus t. Now in this case, what we have is a case where the expression is not similar to this one. You have two separate functions here now. One on the numerator, one on the denominator. And you can't do what some students try to do, differentiate the numerator and differentiate the denominator and just write them like that. So that would be basically 1 over minus 1, right? No, you can't do that. You have to take the numerator separately and call it u, and take the denominator separately and call it v. We're going to use what's called the quotient rule. You have a quotient of two functions. It's like two separate functions divided by each other. It's not like the chain rule here where you have a function inside another function. Here you have a function divided by another function, so you got to use the quotient rule here. All right? If it was multiplied by another function, you could use the product rule. All right? This could in fact be turned into a product as well if you wanted to. You could write it as t times 2 minus t to the power of minus 1 and could proceed, but I think that's more complicated. So let's just use the quotient rule as we have a quotient of two separate functions. So you write the numerator as u and the denominator as v, and then you take the numerator and you differentiate it. In this case, that's going to just become 1. And then you take the denominator and you differentiate again. That's going to become this time minus 1. And then for the quotient rule, it's very simple. I mean, you don't even have to memorize any formula, although the formula is given to you. But what we can do is, if you just remember, this is easy. So you set it up in this way: u first and u dash underneath, then v dash underneath. You just multiply these two together. So it's 2 minus t multiplied by 1. Then minus, for the quotient is minus, and then you do the same with these two. You multiply these diagonally together. So you have t times minus 1, and you divide that by v squared. So it's 2 minus t bracket squared. Now simplifying that will give us dx dt. So here you'll have 2 minus t plus t, 2 minus t plus t over, and leave this in its bracket. We don't need to expand it. The t's cancel out, so you can say that dx dt therefore is going to be 2 over 2 minus t all squared. All right, so that's dx dt. Now we want to find dy dx, so we can just use the chain rule as we set up here. So we know that dy dx is equal to dy dt times dx dt, as we mentioned. So we have both of those now. We have dy dt, which is over here. That's minus 1 over 1 plus t all squared, times, now if times the dt dx, sorry, my bad here, that's dy dt times dt dx, not dx dt, because you have to write it as a reciprocal, then the t's cancel. So dt dx here, okay, dt dx is the reciprocal of this, so it's going to be 2 minus t all squared divided by 2. So you multiply this by 2 minus t all squared divided by 2. So we can therefore say dy dx is going to be minus 1 over 2. So that's minus 1 over 2. That's that number. And then you'll have on the numerator 2 minus t squared, and on the denominator 1 plus t squared. Now they want us to write the answer in this form here, where these two are in one kind of as one fraction all squared, and it's exactly the same thing we have here. Just like, for example, if I said what's 5 squared over 6 squared, well, it will be the same as 5 over 6 all squared. That's 25 over 36. That's also 25 over 36. So I can write this as one bracket all squared as one fraction. So dy dx equals minus a half, and then I have one fraction 2 minus t over 1 plus t all squared. And that's what we had to show. Okay, so that's what we've done there, right? So we've shown that dy dx is equal to minus a half times 2 minus t over 1 plus t in brackets all squared. Okay, good. So that's part A done. Now for part B. It says find an equation for the normal to the curve at the point where t equals 1. So they told us, of course, the parametric equation, and we'd had to show this dy dx equals. So in this question, supposing you couldn't do part A, it doesn't mean you just give up the whole question. Here, we are quite capable of doing part B without having shown this. If we didn't know how to show this, well, we've got dy dx. That will help us to answer this question. Well, now what they're asking you to do is to find the equation for the normal to the curve. Now, I'm just going to draw a random curve shape here. I'm going to draw a straight line. The normal to a curve, okay, is a line which is perpendicular to the tangent to the curve. So, for example, if this is the tangent to the curve at the point P, say this is the point P, right? Then the normal to the curve at the point P would be a line which cuts the tangent at that same point, but it's at 90 degrees to the tangent. So it's perpendicular to the tangent. So this would be the tangent, and this would be the normal. All right. So they're asking us to find an equation for the normal to the curve at the point where t equals 1. So to find the equation of a normal, now normal is a straight line. Okay. For straight lines, we need two pieces of information to find the equation of a straight line. One of the things we need is the gradient. Okay. So we need the gradient of the normal. Okay. And the other thing we need is the point, the coordinates of any point in the line. If we have those two things, we can use the formula y minus y1 equals m times x minus x1. So as long as we have a point on the line, which will be x1 and y1, and we have the gradient of that line, we can find the equation to that line. So that's what we need to do. We need to find a point on the line. So let's do that first. Let's find a point on the line. We know that we want to find the normal to the curve at the point where t equals 1. So when t equals 1, we can see that x will be 1 over 2 minus 1, which is 1. Okay, so we can say that the point that we call P, the x coordinate is 1. And when t equals 1, y is equal to 1 over 1 plus 1, which is 1 over 2. So P 1.5, that is, those are the coordinates of the point. We got that now. Next, we need to find the gradient of the normal to the curve. Now, when t equals 1, dy dx is equal to, as you can see from here, dy dx is equal to minus a half times, and you have 2 minus 1 over 1 plus 1 squared. T is equal to 1, right? So that's going to be minus a half times, and this is going to give you 1 over 2 all squared. Okay, so what will that give us? That will give us a half times a quarter, which is 1 over 8. So minus 1 over 8. So that's the gradient of the tangent equals minus 1 over 8. And we know that the normal is perpendicular to the tangent. So the gradient of the normal is going to be the negative reciprocal of the gradient of the tangent. So if the gradient of the tangent is minus 1 over 8, the gradient of normal, you change the sign, so it becomes positive, and you turn it upside down, so it becomes 8 over 1, which is 8. So now we have this as well now. We have these two things. Okay, so we have the gradient of the normal, and we have the point that we're going to use, which is 1.5, and that's enough now for us to find the equation of the line. So we're going to have y minus y1 equals m times x minus x1. So y minus the y coordinate of the point, which is a half, equals m, which is 8, times x minus the x coordinate of that point, which is 1. So now we can solve this. We can say, okay, y minus a half equals 8x minus 8. So y equals 8x. You have minus 8 plus a half, which is minus 7.5, which is minus 15 over 2. You can leave your answer like this because it didn't mention any form to write it in. Find an equation to the normal. So you can leave your answer like this if you want, that's fine. If you want to write it in the form ax plus by plus c equals 0, you could multiply everything by 2, in which case you'll get 2y equals 16x minus 15. And then you can write this as 16x minus 2y minus 15 equals 0. You could write it like that if you wish as well. 16x minus 2y minus 15 equals 0. So multiply everything by 2. Okay, so that's also possible. So both of these are perfectly good ways of writing the answer to this question. Okay, you can write it in either of those two ways. And there we have answered part B of this question number 3 from the end of topic worksheet. Now we're going to go on to part C. Okay, now part C says, show that the Cartesian equation of the curve can be written in this form y equals 1 plus x over 1 plus 3x. Now again, this is one of those questions where you don't need any of the previous questions to answer it. Okay, so if you didn't know how to do A or B, you could get these 4 marks for C if you know what you're doing here. So then none of these parts depend on the previous part. Okay, so it's something that you should never just give up on part A if you don't know how to do part A. Always look at the other parts, and see if you could salvage some marks from those. Now, show that the Cartesian equation can be written in this form. So now what we're going to do here, there's 2 ways we could go about this. Okay, we could show that when you replace the x's here with what t is in terms of x, so replace these with what t is in terms of x, that you'll end up showing that y is equal to that. That's one way you could do it. So you could, for example, make x the subject of this formula. Okay, so let me do that word. I'll show you method 1 first, and then I'll show you another method. Okay, method 1 could be where you make x the subject of this formula. So you have x equals t over 2 minus t. So if you make the t the subject of this formula, you multiply both sides by 2 minus t. So you have x times 2 minus t equals t. Expand the bracket, so you have 2x minus xt equals t, and bring the t's together. So you have xt on that side plus t equals 2x. And then what you can do is you can make t the subject. So you take t as a common factor, so you have t times x plus 1. On this side you have 2x, then divide both sides by 2x plus 1. So you have divide x plus 1. So you have 2x over x plus 1 equals t. All right, so that's one thing you can do. All right, make t the subject, and then you can substitute that inside this expression. Okay, so yeah, so instead of this t here, we can write what t is equal to. Okay, in terms of x. So what we're going to do now, we can take y equals 1 over 1 plus, and instead of t, I'm going to write what t is in terms of x. So I'll have 2x over x plus 1 I'll replace that t with 2x over x plus 1, and then hopefully what comes out is exactly this. So let's see what happens. So I'll write this as 1 divided by, and all of this, I can write this now as one fraction. Okay, so I'll take away this bracket because it's not really necessary. So I can write this as one fraction here in the denominator. So I put the 1 divided by, so the top, just to make it less confusing, 1 divided by, and I'm going to make this into one fraction. So this is going to have a denominator of x plus 1. So this will be x plus 1, one common denominator, and that will be x plus 1 on top there, and I'll have plus 2x over here. Okay, so that's the next step there. So I've made this into one fraction. Okay, so I made the common denominator of x plus 1, that becomes x plus 1 plus 2x under one common denominator. Now that's y equals 1 divided by, and here I'm going to have 3x plus 1 over x plus 1. Okay, and if you do 1 divided by something, it's like 1 multiplied by its reciprocal. So it's 1 times the reciprocal of that, which is x plus 1 over 3x plus 1. So we end up with y equals x plus 1 over 3x plus 1. So we have found the Cartesian equation 1 plus x over 1 plus 3x. Okay, we just written the other way around, it's no problem. It's the same as 1 plus x over 1 plus 3x. It's the same thing. Okay, just written the sum the other way around. It's the same exact thing. All right. So that's one method of. Okay, now for a second method of answering part C, what we can do is we can take the x term, like here, replace it into this equation instead of x, so we have y in terms of t, and show that that gives us what y is in our parametric equation. So if I replace x in the equation, the Cartesian equation, with t over 2 minus t, with t over 2 minus t, and I arrange that algebraically, rearrange it, manipulate it, I should end up with this y equals 1 over 1 plus t. If I do, then I know that this is the Cartesian equation of the curve. So that's an alternative method of solving this problem. Okay, so what we're going to do now is we're going to replace the x with t over 2 minus t. So 1 plus t over 2 minus t divided by 1 plus 3 times t over 2 minus t, which becomes 3t over 2 minus t. Now, to make it less complicated to the eye, I'm going to write this as 1 plus t over 2 minus t divided by the other denominator, 1 plus 3t over 2 minus t. And hopefully, when we finished, this will be what we get. We'll get y equals that. So y equals, now this, I'm going to write it as a single fraction with one denominator, common denominator of 2 minus t. So this is 2 minus t plus t over 2 minus t. So the numerators add together 2 minus t plus t under that one single denominator. Similarly for this one, I'll do the same thing. I'll write this as 2 minus t as a single denominator. So that becomes 2 minus t plus, and that's 3t. Okay, so if you simplify this, this is 2 minus t plus t, which is just going to give you 2 over 2 minus t, and divided by, and this is going to be 2 plus 2t, 3t minus t, 2 plus 2t over 2 minus t. So now let's see what happens here. What we're going to do now, you got y equals, now this we can divide, well, this division will turn into a multiplication, and that will be the reciprocal, so it'll be 2 minus t on top and 2 plus 2t underneath. They will cancel out, so we're left with 2 over 2 plus 2t, and I see there's a common factor in the denominator of 2, so you have 2 over 1 plus t, the 2's cancel out, and you're left with 1 over 1 plus t. So we can say that therefore y equals 1 over 1 plus t. So we can see now that we've got exactly what y is. So we can say that when x equals t over 2 minus t, then we can say then y equals 1 plus 1 over 1 plus t. Okay, when we substitute x as t over t 2 minus t. Okay, therefore, okay, Cartesian equation is correct because we got exactly, it satisfied the equation, right? When we put the x term into there, what came out? Exactly the y term. That means these two satisfy the Cartesian equation. All right, so that's one way of doing it. Okay, I think the first way is better, where we basically took we made the t the subject of the formula, okay, and we replaced that t into the other equation. So we had our equations here. I've just copied them down here. Okay, so we had these equations here. Okay, and we took this equation, all right, and what we did is we made t the subject of this formula here, and replaced that t into where t is in the y, into the y formula, and we found that it gave us exactly what we had to get, or exactly what the equation is, right? So that's probably the easy way of doing it, and that's the way you would do it if you didn't know the Cartesian equation first. So if they didn't tell you what the Cartesian equation was, if they just said find a Cartesian equation for this curve, right, then you would have to do this method. There's no choice. You would have to take like the x value, make t the subject of that, and replace that instead of t in the y part, and then you have y in terms of x, eliminating the t from the equations. You'd have to do that, right? But because they gave us the Cartesian equation itself, we can show that these two satisfy them. If you substitute one of them into the other, okay, if you substitute one of them in terms of t, you'll get the other. So I put x in terms of t, and I found that y gave me exactly this. So that's also perfectly fine method of showing this, right? But you should know both ways, because sometimes they don't give you the Cartesian equation. They'll say find the Cartesian equation, not show. So therefore you'd have to do this method here. So that's just a couple of ways of answering this last question. I hope that was clear. Thank you for watching. Other questions from this particular Solomon F paper from the old C4 will be found in the playlist that will appear over here. Okay, other questions from this end of topic worksheet on parametric equations from my P4 collection will be over here. Other questions from parametric equations in general in P4, you'll find them in the playlist that will appear in this region at the end of the video, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.